So in order to find the moles of this acid, we need to find the moles of hydrogen gas that formed. So to do that, we need PV equals nRT. We have the T, we have the P, we have the V. And it's important you see that we need to use the V of the gas. We know R. I'm going to go ahead and change this P to atmospheres. 747.5 divided by 760.
It's about
0.9836 atmosphere. I want moles, so I need to rearrange this equation. Take out R and P. Times the V, 1.21 liters. 0.0821. All of those good units that we have cancel out everything. And then the temperature, 294 Kelvin. So 0.9836 times 1.21 divided by 0.0821. All those good units cancel out here, except for moles, and then divided by 294. So we get 0.049 moles. With looks like 3 significant digits. Yep, 0.9836 times 1.121 divided by 0.0821 divided by 294. Otherwise, you got to use brackets, right? Yep. So we get that many moles. Well, we need a formula. HCl plus zinc yields zinc chloride plus H2. So this is H2. For every 1 mole of H2, we need 2 moles of HCl. Then we're going to take that 0.493, we'll multiply it by 2. We get 0.0986. Moles of HCl. It has 800 liters, 800 milliliters, so we need to divide that by 0.8 liters. And we get 0.123 molar. So you can see with the stoichiometry, it does bring a lot of cool different ways. Anything that allows you to deal with moles, you can come to a stoichiometry thing, or you can use a stoichiometry thing to get to it. Or you could use the PV equals nRT to get moles and then plug it through a stoichiometry thing. That's the thing. Remember, like when scientists are doing something, they have to find a way to do what they want to do. Everything is not just a planned procedure. You go in, you collect some data, you sit there and then determine how you can work about that data to determine what you want to determine. It's not the consumer world, right? Where every, every Kool-Aid uses 1 cup, or, it's not that world. All right, so everybody that's in here, do you have an amount of grams of cobalt 2 nitrate that you figured out yesterday? It is. You were supposed to. So you should have an amount of grams of this. And you know the volume of water that you need, right? How much do you need? Yeah. So the paragraph for yesterday was just typed out. It was create 100 milliliter solution of 0.200 molar cobalt 2 nitrate hexahydrate. That's what the lab is. Right? So what is the mass that we all agree upon? People from home? You guys want to type it into the chat all at the same time? Go.
Is it like 5.8214 grams? Is it like what we got when we used? Wait, never mind. I don't know.
It sounds fine. 5 point what?
8214 grams.
5.8214 grams. Is that what you guys got? Are you sure? Yeah, that's awesome. Cool, cool. Everybody else? We comfortable with that?
I think my group, we used 0.2 instead of 0.009, and I did it with 0.009 because that's how many sig figs you were supposed to round to, and I got 5.8476.
So in the end, we're only going to be good to 3 sig figs, right? But in reality, our scales, this will actually be up to 100.00, and our scale will be able to go out this far. So you could actually get this out 2 more as well. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you're saying that whenever you did it, you got something other than 5.821, you got 5.84?
Well, no, I just used instead of going like rounding to 0.200, I did 0.2009 because I rounded to 4 sig figs because that's how many like there were. And then I got like something a little bit bigger. I got 5.8476 or 5.8.
I think that the issue is this, is that we actually, the solution that was created from the other one was 0.2009, but the one we want to make in the laboratory is 0.20000. We want to make it as close to that. And what's going to happen, you're going to see this in the laboratory, is they're not going to be able to get exactly 5.8214.
Mhm.
So they will have to go with whatever they end up with closest to this, make the solution, and then they will have a different molarity here.
Okay.
They won't have 0.200. Maybe they'll have 0.201 something something, or 0.1999 something, right?
Mhm.
And that's key for them to keep too, right? If everybody sits there and says, "Oh yeah, we got 0.2000," the same thing, then we know that they're fudging their numbers. But that's the key. Let's make sure this is right before we make a bunch of solutions that are not right. So what is the molar mass of this carbon, the cobalt nitrate hexahydrate? Can we all agree that it's 291.07? If you have something in the 180s, doesn't that mean that you didn't add the water? So that's also needed. So we want 1 unit on this. So we're going to start off with 100.00 milliliters. Every 1,000 milliliters is 1 liter. Every 1 liter should have 0.2000 moles. Every 1 mole is 291.07 grams. So 100 divided by 1,000 times 0.2 times 291.07. That gives me that 5.8214. All right. So let's try this. Dun, 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 dun. So here's what I need to do this. Volumetric flask, and you guys can look either live or on the camera. It's up to you entirely. That line right there is 100.00. I'm going to use a 50 milliliter beaker. because it's small and I can pour it. So I need to clean this out. Again, I don't know what happens to you guys, but you guys are like, I got to do stuff, and you always forget to clean it. Something in here is probably going to cause a lot more air than anything else. So we clean that and I dry it because moisture will add mass to it, right? So I want to make sure I dry it. I have my wet dry there, and then basically one that's already gotten wet to dry off the most of it. And then I've got a second part of a towel to make sure I get any others. I notice I'm only using one towel today. Sometimes I come back here and there's like 30 towels at one place. Just because I got this a little bit doesn't mean I can't like use that for other stuff, right? I'm gonna try to be less wasteful. So I've got that beaker. I'm gonna use this to measure my mass. So at each desk, there is some cobalt 2 nitrate. It just looks like a salt, like almost like what's that guy's seasoning salt? Laris. I need a scupula. And remember, beakers and scupulas are all in the same drawer. It's the top left drawer. So I'm going to put the beaker on here. Right there's my beaker. I don't know if you guys will be able to see this as well. That's not my beaker. Right there's my beaker. I'm going to zero this. The way these scales are designed is that you can open up both of these doors, and that makes it nice because I can reach through with my scupula on this side and reach through with my chemical on this side. And basically all I want to do is get, what number did we say? The hexahydrate is in this. So remember, the hydrate is basically water is absorbed into this powder. We can't see it. 5 point what? 5.8214. We're real close now. We're only gonna have 4 significant digits with this scale. Sorry about that. So 5.8214. So I've got 5.833. I don't know if you can even see that. 5.832. I have some options here. They're gonna waste a lot of time. I can sit here and try to get 5.821, but it's probably not going to work. Now I've got 5.824. That's good enough. I'm going to use this mass that I have here for my molarity of my solution though. So I need to go back and calculate the molarity of that solution. You guys are going to need like a sheet of paper or something that you're going to keep. Like I can give you blank paper. There's no write-up right now because all we're doing is making the solution, right? So here's the thing. Don't leave your scrupula by this and make sure you put it back here. This is my solid. I've got to get this solid into this hole. If I try to do this, not going to work well. I don't care about any amount of water in here until I'm at the end. So you after you give this a good look over and cleaning, just put some soap and water in there and mix it around. Make sure you rinse it out well. If you put soap in there, rinse it out well with regular water. And then the last thing is give it a few squirts of distilled water. And we don't care about any amount of water in here, because all we want it to be is that we want it to be at 100 when we're all done, right? So what I can do now is I can add water to this. And hopefully I can get all that to dissolve in there. And then I'm going to carefully pour this into here. Now, the only big problem is I've got to get all of this out of here by the time that we reach 100. So it's kind of a game. So what I'm going to do is I'm going to take that just like that. Give this one last swirl. And if you can see any particles at all in there, then you would just keep giving it swirls. Or if you think you're awesome with this thing, you can sit here and go like this and be like, yeah, I'm getting all of it. Until you get it all in here, give it a few swirls. And now we just want to raise this water level up to that line. So this is where we go like this. And depending on your skill level of using one of these, you can sit here and take the top off and pour into here. If you're weak wrists or whatnot. And then you can add to here, just like this, because all that matters is that in the end, we get up to that 100, right? So it's gonna take at least 2 of these. Now the hardest part is right when you get to that 100, because if you go over, you got to restart the solution. If you're under, you can always do what? Add more. I'm not sure if this is going to get caught on the camera, but watch what happens as soon as you start to get to that neck. It gets really difficult to add some because it goes very quickly, right? So I got it up to the neck. I'm happy with that. What I might do is put a little bit of more water in there, but I'm going to get as close to that line as I can. And then I'm going to put, using a dropper, I'm going to take it up to what I need to. That's probably the best way to do it. Remember meniscus at the bottom of it? And there we have it. We've made it. And now what we'll do is we'll put a cap on there. And then next week we'll check to make sure that line is still there. As it's all mixed up, that line may go down and we may need to add a drop or 2 of distilled water. But that's the basis of making this solution. We made our 0.2 molar solution and we have 100 milliliters of it. Let me see if I have one of the caps so I can show you that aspect. Yeah, real quick.
So when do you find the water?
After you're done with this aspect right here, then you can find them later.
But when do you just buy like the whole?
You can take the grounds and find the holes and go from there. Yep. Yeah. Get this couple with them.
Divided by 1.1.
Yes. And there we have it. I'm going to let this sit here and make sure that I don't need to add any more water or anything like that because there is some on the walls. And that's what we'll be checking for next week. The biggest other thing that these students need to do today, and make sure you remind them of this, they need to write on there their initials or some type of identifying factor. Markers are right here, guys. The way we do this is you always bring your thing through the marker. Otherwise, the markers get places and nobody knows where they are. You're going to write an identifying thing on there like your initials. Right? And then you need to write down the molarity. You can write it on here too, but that's it. There is our solution. Questions from those of you in here? Questions from those at home? All right, I'm going to go ahead and, oh, there's a question. There's something here. You guys know I'm not good at the chat things. Oh, 5.86, I'm not sure what that's referring to, but, oh, that was the number. Okay, cool. All right, you guys are on Zoom? So I'm going to go ahead and open up a room, breakout room. We have 1, 2, 3, 4. I'll create those.